It's time for Chapter 5, Section 3. This is Mrs. Norris. It's time for another video, and we're going to do a quick warm-up. So let's start by looking at these number 1 and number 2. It's asking us to find the x-intercept. If you remember during the cover-up method, that's where we made y 0. In our example, our y is right here. So if we plug in 0 equals negative 3x plus 9, we subtract 9 from both sides and divide by negative 3. We get a 0, or an x-intercept of 3. We can do the same on this side. We can plug in 0 for f of x. We can subtract 4 from both sides, and we can get an x-intercept of negative 2/3. The bottom three we've been working on the past few days, and so let's review, make sure we remember how to factor. These two have a GCF in them. They have a 3 and an x. So we pull out that 3x, and we're left with 3x times x minus 4. In this expression, because our coefficient is 1, we say what multiplies to give you 18 and adds to give you negative 9. The answer to our factors is a negative 6 and a negative 3. So we do x minus 6 times x minus 3. Remember, you can always check yourself by foiling these, seeing if you get the original expression, distributing this, see if you get the original expression. This is a difference of squares, so we take the square root of x squared and 49, and we get x minus 7 times x plus 7. Okay, let's jump into the notes here for section 3. You need to write down that a 0 of a function is an x value that makes the y value 0. It's basically your x-intercept. What you'll notice here, take a second to sketch this graph, is that we have two x-intercepts. Remember, for a linear function, if I were to draw a line here, it only crosses the x-axis once. But sometimes, and oftentimes for a quadratic, since we're in the shape of a U, we're going to cross the x-axis twice. And these 2 points are exactly symmetrical about our axis of symmetry. These x-coordinates right here are called the zeros. Let's find the zeros of this function by using a graph and table. And let's do the similar what we did yesterday, in section 2, not yesterday. So let's go ahead and walk through the steps. I'm going to put up here our graphic organizer that we filled out, and we're going to fill it in for our function. Remember, we're factoring or graphing to find the zeros. In this example, we're going to practice the graphing side. So we're going to take all of this information. We're going to start over here. Does it open up or down? Opens down, since a is negative. Then we're going to go over here to axis of symmetry. Remember, your formula is negative b over 2a. So we write x equals negative b over 2a, which is negative parentheses b, which is negative 2, over 2 times a, which is negative 1. Substituting all of this in, we get negative negative 2, which is positive 2 over negative 2, which simplifies to negative 1. Remember, to find the vertex, we take this negative 1 and plug it into the original equation. In doing that, you see that we get negative, parentheses, negative 1 squared, minus 2 times negative 1, plus 3. Plugging all of this in one step in your calculator, remembering to use parentheses, you should get a positive 4. This is our y value for this x, so our vertex is at negative 1, 4. I'm going to show you another quick way to find that in just a second. The y-intercept, you remember, is from C, and if you look here in the equation, you can see that our y-intercept is easy to pull out. It is a 3. Okay, so let's take each of those parts and start to get our graph together. Remember, this axis of symmetry is a line at x equals negative 1. So I'm going to go over here to my graph, and I'm going to plot a vertical line at x equals negative 1. The next thing I'm going to plot is the vertex. The vertex, remember, lies along the x equals negative 1 line, and since we get a y value of 4 when we plug that in, we plot the point negative 1, 4, which is right here. Next, we're going to plot the y-intercept, which is a point on the y-axis at 3, and we're also going to plot the point that's symmetrical here at which makes it at -2. Connecting all of these points and remembering that our graph goes down, we see a parabola that looks like this. Now, we learned in the last slide that the zeros exist at the point right here where it crosses the x-axis and the point right here where it crosses the x-axis. So let's show those points on our graph. Those points exist at -3, 0, and 1, 0. So those are called our zeros, and that's how you find it using a graph. Now, jumping back to this PowerPoint slideshow here, here's the graph. Here's the graph that we just did. We have our axis of symmetry at -1, etc., and we show our zeros or our x-intercepts. Remember that you can plug any x value into that equation and find its respective y value. You can do this simply by using the second graph function on your calculator also. I'm going to show you a picture of that in just a second. But let's look at a couple of things here. Number one, we're confirming that we found our correct y value for our vertex because our table comes up on our calculator. We also should notice a unique thing here. We needed to find our zeros, remember? Our zeros exist when y equals 0, so you can see that we have two of those. One at -3, x equals -3, and one at x equals 1. So these are called our zeros. Let's look at a quick calculator screen for this one. If I pop this, this is what you should see on your calculator, you'll notice that our graph is here. We can use the trace function to find the zeros. We worked on the intersection of that the other day, the intersection function, but let's try the zero function. We'll do a little bit of that tomorrow in class. And we can also hit second graph to look at our table of values and find that our zeros exist when x is -3 and x is 1. These are called the zeros of the function. Now let's practice another vocabulary word, which is called the roots. The roots of an equation are the variables that make the equation true. So the roots, the zeros, are all the same thing. We're going to plug in an x root that makes y 0, which is the same as finding the zeros of the function. All of these words are interchangeable, and you need to know all of them. Roots, zeros, x-intercepts. Please write that down. Roots, zeros, and x-intercepts are all the same thing. Okay, you can also remember that any function will have an x-intercept or a 0, and an equation will have what we call a solution or a root. Again, these words are all interchangeable. Just make sure you understand that we're finding the same thing for all four of these word types. We also remember what we call the zero product property, and this is straight in your textbook. It just says that if the product of two quantities equals 0, then at least one of those two has to be 0, but not both of them. And that's important because we're going to tie our factoring practice into this zero product property rule in just a minute. Okay, so let's tie in all of this factoring that we've been doing to how we use it to find the zeros of the function, and the fact that if we multiply something by 0, the zero product property tells us that either one of those things can make it 0. So let's pull up our original equation that we just used. If you remember, our zeros occurred at -3 and +1 when we used the graphing method. Let's see if those same zeros hold true when we factor. So you should have noticed that we have a negative in front of the x squared. That means a is not 1, so the first thing we need to do is pull out that negative. In factoring, we also need to set this equal to 0, so we change the f of x to 0. You're going to set your equation equal to 0 whenever you're solving or finding the roots. Now that we have this in the middle here, and our a is 1, we can say to ourselves, what multiplies to give us -3, but adds to give us +2? The answer is +3 and -1. Those are the factors that multiply to give us -3. Plugging those into our parentheses, we see that we have this parenthesis equal to 0, or because the zero product property says it can be either one, we're going to set each one of those parentheses equal to 0. Now you'll notice that we dropped the negative during this part. You should keep it there when you're factoring, but because it doesn't have an x in it, it will have nothing to do with creating a product that can make 0. So we drop the negative and set each of these parentheses equal to 0. Solving for x on this side and this side gives us an x of -3 or an x of 1. And you will notice that we got the exact same zeros. Because all of the methods, graphing by hand, graphing on our calculator, and factoring, all give us zeros at -3 and 1. These are what we call the zeros of the function. Let's try a couple more. This is example 2. We're going to go ahead and just find the zeros of the function by factoring. This is the original equation, so we need to set the function equal to 0. That's step 1. Remember, we're finding the zeros, so that helps you remember to set them equal to 0. We're going to go ahead and factor and say what multiplies to give us -6 and adds to give us -5. The answer is -6 and +1. Those are our factors. We're going to set each of those parentheses equal to 0. And we're going to get solutions or zeros of x equals -1 and x equals 6. So these red numbers here are what we call the factors. They're what we put behind the x inside the parenthesis. But when we're all the way finished, we're going to get what we call the zeros or the solution. Now we can check quickly to make sure that those numbers that we just found for x, if we plug them in, do in fact give us a 0. So let's substitute each value into the original equation. On the left you'll see a -1 plugged in, it gave us a 0. On the right you'll see a 6 plugged in. Those were our two roots, remember, and if you plug either one of those into the original equation, you do in fact get 0. Let's try one more. You should notice that this one is a GCF type. It only has two parts, and there's a minus sign between them, but these are not perfect squares, so we're just going to pull out the GCF. Remember that we always start finding our zeros by changing this g of x to 0. So we set our function equal to 0 first. Then we're going to pull out an x from each of these two pieces. When we pull out an x, we're left with an x in the first one and a -8 in the second one. Now this time you'll notice that what's outside the parentheses does involve an x. So when we are thinking about the zero product property, this could give us a 0. So we need to put both of them equal to 0. The left side tells you that one of your solutions is 0, and the right side tells us that our solution is 8. These are the x values that would give us a 0 for the original equation. Okay, that's going to be it for tonight. We'll practice a bunch of these tomorrow. Make sure that you've written down at least 1 or 2 questions, please. And if not, then expect to lead your homework group in the example problems. And I will see you tomorrow.